Good morning. This is Dr. Vaughn. I'm going to show you two problems today from Chapter 10. I have the first one here is a rational expression with fractional or rational exponents, a very complex looking kind of problem that we can work through together. And the second one is a radical expression. We want to simplify each one of these. These are a little bit out of order from what you might find in the book. I think the second one is indicative of the kind of problem you might see in section 10.1, and the first problem here is one you might see in section 10.2. But with that, let's get started. This is going to be a lot of different kinds of formatting to do a question like this within the equation editor. It can be very complicated, but on the other hand, this is one of those kinds of problems where the equation editor really helps make this a lot more readable than if you try to do this using text carrots and other kinds of pasting it together using just regular without using the equation editor tools. So here we have a fraction inside the parentheses and a big exponent on the outside. There's a couple of different things that you can do. I would suggest that you start by simplifying the inside of the parentheses as much as possible before you actually start working with the outside. This is part of that please excuse my dear Aunt Sally, resolving the stuff that's in the parentheses before you kind of tackle the exponent after that. So when I look inside the parentheses, just temporarily ignoring the minus 6, I see that I have two different exponents that have a base of x and one exponent that has a base of y. So I will be able to combine those two exponents that have the base of x together by either adding or subtracting the exponents from one another. Now, I have a choice here. I can either move the negative 5/4 to the bottom and make it a plus 5/4, or I can move the negative 3/4 up to the top and make it a plus 3/4. In this particular case, I'm going to choose to take the negative 5/4 on the top and move it to the bottom because 5/4 is bigger than 3/4, and then I'll end up with a positive exponent instead of a negative exponent. So the first thing we're going to do is we move the x, we combine the x x-based terms inside the parentheses. Alright, so now in the equation editor, I have to keep this big parentheses on the outside, and then I also need to have it as an exponent with this power of minus 6. So I'm going to start with the script tool. I'll go ahead and put the minus 6 exponent up in the exponent, and then for the base, I'm going to go to the bracket tool and put in a big parentheses. Now inside the parentheses, I'm still going to have a big fraction, so I'll use the fraction tool, and then on the top, I'm going to leave just the term the y to the minus to the 1/3, which I'm going to have to use an exponent tool for. And for the exponent of being a 1/3, I'm going to have to use the fraction tool again. So you can see all the different kinds of layers of how the exponents and the fractions are embedded within one another. Now in the bottom, when you move the minus 5/4 to the bottom, it's going to become a plus 5/4. So let me write this as I'm going to do this real time just for the sake of keeping this video a little bit shorter. But when you're writing this out, for example, in a worked out homework, you might want to show each one of the different steps. So here I'm going to have the x to the minus 3/4. And then I'm going to add the 5/4 that I get from the other term. Now again, these have a common denominator of a 4, so I can add the numerators minus 3 plus 5 to actually make this 2/4, which I'm going to simplify in one step to be just 1/2. But we'll go ahead and do that on a separate line. So again, we'll do the big script for the minus 6. We'll do the parentheses. We'll copy all of the stuff that's inside here and just paste it in over here. And then in the denominator, I'll just fix these exponents to put a 2/4, which actually I could reduce to be just 1/2. Okay, so now we actually have to apply the big exponent of the -6. So the rule is when you have a big parentheses and you have the numerator and the denominator, you need to apply that exponent of -6 to both of the different terms. So I'm going to take y to the 1/3 raised to the -6, and then x to the 1/2 raised to the -6. So I can show that step by just doing a big fraction now. And then in the numerator of the big fraction, I'll have my parentheses, the y to the 1/3, I think I can just copy that also. And then I can raise this exponent, use the script tool again to raise it to the -6 power. And then in the denominator, I can do the same thing with the x to the 1/2, copy that over, put it in a parentheses, and then raise the whole thing here to the -6 power also. See, I lost my script tools here. Let's see. There we go. All right, and now I'm going to apply when you have an exponent raised to an exponent, you multiply those exponents. And I should continue my sentences. So I multiply the 1/3 times the -6 to get -2. And in the denominator, I put the x to the 1/2. 1/2 times -6 would be -3. Just going to tab this over a little bit. All right, now the last thing that we can do is when you have negative exponents, you can switch the sides of the fraction. So the -2 on top can come down to the bottom and become a +2, and similarly the -3 on the bottom can come up to the top and become a +3. So switching the sides, and this will be our last step. So just write this as a fraction. On the top we'll have x to the 3rd, and on the bottom we'll have y to the squared. All right, so that's the end of the first problem. You know, we had this very ugly looking kind of thing with all these fractions, and in the end it resolved itself actually quite nicely to something fairly simple, although it did take a little bit of steps to get there. All right, so now we're going to copy down our next problem. This one won't take nearly as long. The one thing we want to do here is again work inside of the radical, inside of the parentheses. Looks like I lost a minus sign somewhere. We first factor the inside. So x squared minus 16x plus 64 factors into the perfect square x minus 8 times x minus 8. So we're going to write this as a perfect square trinomial inside of the radical. So I still have the big minus sign outside. I still have the radical symbol. And then I'll write the parentheses. And it's going to be a perfect square, so I'll give myself room to put that square operation in. There's the square. And it factors into x minus 8 times x minus 8, or x minus 8 quantity squared. Now, here we have, I'm going to just ignore the minus sign for just a minute and look at the radical square root of something squared. So the square root of x squared is not actually equal to just x, it's equal to the absolute value of x, because the value of the radical, when you take a negative number and you square it, it becomes positive, and then when you take the square root of that, you always get just the positive square root back. You don't get the negative square root back. Now we're going to get the negative because of the negative outside, but that's a separately applied kind of negative. So ignoring the minus sign for a minute, the square root of x minus 8 quantity squared would be the absolute value of x minus 8. So let's just write this in two steps so that it's clear. So since the square root of, say, x squared is equal to the absolute value of x, we have that, just copy all this over. That if I replace this x with the quantity x minus 8, then I can replace this quantity with x minus 8. And in particular, the expression above simplifies to just the minus sign that was sitting out here in advance, and then the square root of x minus 8 quantity squared simplifies to just the absolute value of x minus 8. And that's it. So I hope that this has been useful to you, and I look forward to talking to you again. Have a great day.